Hello guys, I'm Kushani Jayasuriya and I'll be explaining the unit number 9, Microbiology, and this will contain the context of the first 6.5 pages. That means it will be explaining about microorganisms as well as bacteria. This is always based on the national A-level curriculum. I hope this video will come in handy and help in your learning process. Right, now let's begin. Today's topic, the unit will be microbiology. I will be starting on the question, what is microbiology? Microbiology is the study of organisms that are too small and they are not visible to the naked eye when they exist individually. So in these definitions, there are 3 important points. Too small. Then, the next important point, not visible to the naked eye. Next important point will be when they exist individually. Now that is very important because some microorganisms are visible to the naked eye when they exist in colonies or as groups. So, the existing individually, this section is extra important for this definition. All microorganisms are not visible to the naked eye when they exist individually. So, the definition is organisms, the study of organisms that are too small and not visible to the naked eye when they exist individually. So under microbiology, we are going to learn about microorganisms, molecules, viruses, viroids and prions. Under microorganisms, we are going to talk about bacteria, archaea, cyanobacteria, protista, fungi. Cyanobacteria is also known as blue-green bacteria. Then molecules, under molecules there are 2 types, mycoplasma, phytoplasma, and together with viruses, viroids and prions. In this video, I will be explaining about microorganisms in general and about bacteria in detail. Now let's move on to discuss about microorganisms. You all know that microorganisms are microscopic. They are microscopic because of their size. Their size is less than 0.1 millimeters, so they are not visible to the naked eye. And as well, so in order to view microorganisms or their structures, we have to observe them through the microscope. And then we use units such as micrometers, nanometers to give the size of the microorganism or their structures. That will be 10 to the power minus 6, 10 to the power minus 9 meters. Then next we'll move on to an interesting section, that is a very uncommon word, ubiquitous nature of microorganisms. What is ubiquitous nature of microorganisms? That means their ability to be found anywhere on the earth. They may be found in water, or they may be found in soil, They may be found in air, also they can be found in interior and exterior surfaces of other organisms. When talking about microorganisms who live in water, they may be living in marine or freshwater. However, all the microorganisms who live in water, they form the basis of food chains in aquatic environment. Some of these microorganisms who live in water, they perform photosynthesis. They do photosynthesis. Therefore, they are primary producers of aquatic environment. Then next we talk about microorganisms living in soil. They help to recycle chemicals in soil between soil, air, water and living organisms. Right, that's all for microorganisms living in soil. Then let's move on for microorganisms living in air. Microorganisms who are suspended in air are known as bioaerosols. They can travel long distances through the wind current and then they can precipitate, which means they can land on a surface. What will happen if these bioaerosols are pathogenic? They will cause to spread diseases. Then microorganisms who are associated with plants and animals, when we talk about them, the majority of such microorganisms are advantageous or they are harmless. But a minority of them are pathogenic, so they can cause diseases inside the living organism, that is a plant or animal. So that's all about the ubiquitous nature, and they are found in water, soil, air and associated with plants and animals. When we talk about viruses, when we speak about their harmlessness or harmfulness, we can say that all viruses are pathogenic. Once they land on a living surface, that organism will be having a disease. That means all viruses are pathogenic on a surface, on a living surface. Then in addition to these four places where microorganisms are found, microorganisms are also found in another place that is a very special place. where other organisms cannot survive. That is, extreme environments. Other organisms cannot survive in such environments. It can be unfavorable or even lethal for other organisms. Microorganisms who live in extreme environments are called as extremophiles. They may be living in deep sea with high pressure, or they may be in places with acidic pH or alkaline pH, hydrothermal vents, etc. Based on the extreme condition that the microorganism is adapted to, extremophiles are categorized. Thermophiles. Psychrophiles. Acidophiles. Alkaliphiles. Halophiles. Last one, barophiles. Thermophiles can tolerate high temperature. Then psychrophiles can tolerate low temperature. Acidophiles can tolerate acidic pH. Alkaliphiles can tolerate basic pH. Halophiles, they require sodium chloride. Then barophiles can tolerate high pressure. If we take an example of extreme environments such as deep sea. Deep sea has both low temperatures as well as high pressure. Therefore, any microorganism who is living in the deep sea can tolerate both low temperatures and high pressure. Therefore, such microorganisms or any microorganism who live in extreme environments are adapted to more than one extreme condition. Right. Then this section is over. Then let's move on to the growth rate of microorganisms. Growth rate. What can we say about the growth rate of microorganisms? Is it high or is it low? It is probably high. The growth and reproductive rate of microorganisms is high. Right? This is because microorganisms has a high surface area to volume ratio. This ratio is extremely high. That means they have a large surface area to exchange materials with the environment. Then the flow of nutrients into the cell and the flow of waste materials out of the cell is high. Therefore, they have high metabolic rate. Therefore, their generation time. Average generation time, or the time taken to double the population, is relatively less. Related to other animals or other organisms, it is less because they have high metabolic rate. Right. So the growth rate, this is the reason why they have a high reproduction and growth rate. Now we have to talk about the features, that is features of microorganisms, the morphological, physiological and nutritional diversity of microorganisms. First we will talk about the morphological diversity. Morphological diversity. We have to talk about the morphological diversity of bacteria first. Bacteria has 3 different shapes. What are the shapes? Rod shape, that is bacillus. Spherical shape, coccus. Spiral shape, spirillum. Then next, we have to talk about cyanide. Cyanobacteria has a wide range of morphological diversity, from unicellular to multicellular, large multicellular filaments. These multicellular filaments may be filamentous or non-filamentous. The filamentous cyanobacteria, they form a chain. Non-filamentous cyanobacteria form clusters. These clusters may be in the shape of spherical, cubical, or in an irregular shape. Then that's all for cyanobacteria. Then we have to talk about viruses. When we talk about the morphological diversity of viruses, it is usually based on the symmetry of their protein coat, that is icosahedral and helical. Then the next section, that is fungi. In fungi also there are unicellular as well as multicellular fungi. Multicellular fungi is formed of hyphae. This hyphae may be septate or aseptate. Hyphae of a multicellular fungi together form mycelium in multicellular fungi. Right. Then the next one is prions. About prions there is nothing much to discuss. They are smaller proteinaceous particles. Smaller proteinaceous particles. Protista. Here we are talking about the unicellular protista, of course. They have a wide range of morphological diversity. Then the last one is molecules. they are pleomorphic. Pleomorphic means they have a variable shape. Now this is the morphological diversity. Next we will move on to the nutritional diversity. Nutritional diversity. Based on the source of carbon and energy, there are 4 nutritional types. Chemoautotrophs, chemoheterotrophs, photoautotrophs and photoheterotrophs. That's all. The next, physiological diversity. This is based on the utilization of oxygen. Obligate aerobes, obligate anaerobes, facultative anaerobes, microaerobic. Then there is another section in this physiological diversity about the nitrogen fixing bacteria. In this nitrogen fixing bacteria, there are 2 types, free-living and symbiotic. That's all. Now we can move on to learn about one type of microorganism, that is bacteria. Now we have to learn about bacteria in detail. Bacteria. Right. Bacteria, they are unicellular and they are prokaryotes. They have a wide range of morphological diversity as well as their cell arrangements also have a wide range of diversity. The most obvious structural feature of bacteria is their shape. There are 3 different shapes: spherical, rod, spiral. Spherical shape, they are known as coccus. Now we have to learn about the different cell arrangements that the spherical shaped bacteria is having. Coccus. They have one plane of cell division and the cells separate after cell division. Then Diplococcus. They also have only one plane of cell division, but they remain in pairs after cell division. Then Streptococcus. They have only one plane of cell division, but they form chains. They remain attached as well. They form chains. Next, Tetrad. They have two planes of cell division and the cells remain attached. Sarcini. They have three planes of cell division and the cells remain attached after the cell division, similar to the above three. Then the last one is Staphylococcus. They have multiple planes of cell division, and they form a grape-like clusters of cells. They remain together after cell division. Then next, rod-shaped bacteria. Single bacillus is the first one we are going to discuss about. Single bacillus, rod-shaped. Diplobacillus, remain in pairs. Streptobacillus, they form chains. Then the final shape we will talk about spiral. Vibrio, a curved rod. Spirillum, they are helical in shape, like a corkscrew, and they have a rigid body. That is very important. They are rigid. Then spirochete. They are also helical, but they have a flexible body. So this is like a short note about spherical, rod and spiral-shaped bacteria. Now we are moving on to the last section of this video. That will be the nutritional, physiological diversity and how bacteria reproduce. When we talk about the nutritional diversity, photoautotrophs, their source of energy is light, and their source of carbon is carbon dioxide, which is inorganic carbon. And then examples: purple sulfur bacteria and green sulfur bacteria. Then photoheterotrophs. Their source of energy is also light, but the source of carbon is different, that is organic carbon. Then examples: purple non-sulfur bacteria. Then next, chemoautotrophs. Their source of energy is inorganic chemical. Source of carbon, carbon dioxide, that is an inorganic carbon. The examples: Nitrobacter, Nitrosomonas, Thiobacillus, Capsules. Then next, chemoheterotrophs. Their source of energy is organic chemicals. Source of carbon is organic carbon. Examples: most bacteria. Then next, we will move on to physiological diversity. Physiological diversity, we have obligate aerobes, obligate anaerobes. First we discuss about these two. Obligate aerobes, they require oxygen for their survival. That means they grow in places where there is oxygen, where oxygen is found. And they produce energy through oxidative phosphorylation. Examples: Acetobacter species. Obligate anaerobes. They can survive in places where there is no oxygen, where oxygen is absent. And they produce energy by fermentation. Example is Clostridium species. Then the next one, facultative anaerobes. Facultative anaerobes. They prefer oxygen present environments, and then they can produce energy by oxidative phosphorylation. But they can also survive in anaerobic conditions by producing energy through fermentation, similar to obligate anaerobes. That means they can act both as obligate aerobes and obligate anaerobes. Examples: Escherichia coli. Example is Escherichia coli. Then next, the final type of physiological diversity, that is microaerophilic. Microaerophilic, that is these microorganisms are found in areas where the oxygen concentration is less than those in air. For example, that is Lactobacillus species. Lactobacillus species. And also, as I mentioned in the previous explanations, the nitrogen fixing bacteria. There are two types now: free living and symbiotic. So free living forms, the example is Azotobacter species. Symbiotic forms are the Rhizobium species with legume roots. So now this section is also over. Next we have to talk about the reproduction of bacteria. Bacteria, the reproduction, mostly asexual reproduction occurs by binary fission, and sometimes asexual reproduction can occur via fragmentation and budding. In rare occasions, bacteria of two strains exchange their genetic pieces of genetic materials through a process called as conjugation. This is a very, very rare occasion. So these are the methods of reproduction done by bacteria. I would like to thank everyone who watched this video and to everyone who gave me this opportunity. So thank you for watching this video.